Welcome, data architects and engineers. Today, we are exploring a critical architectural decision in Snowflake Cortex cross-region inference. Let's get started on understanding how to access global AI models while mastering latency, cost, and data residency. Let's begin by defining exactly what cross-region inference is in the context of Snowflake Cortex. Inference is simply the act of giving a model an input and getting an output. By default, Snowflake attempts to run your AI functions using compute resources located in the exact same physical region where your data resides. However, deploying massive large language models requires specialized GPU hardware, meaning not every frontier model is available in every single cloud region. Cross-region inference solves this limitation. It is a powerful capability that allows your Snowflake account to process an AI request in a different region from your default region. This means if your data is sitting in a region that only supports smaller models, you can seamlessly route your complex queries to a remote region hosting the massive, state-of-the-art model you actually need, without having to manually migrate your databases. Look at this flowchart to visualize the routing architecture. On the left, we have your Snowflake account operating in its local region. When you submit a request, such as a call to the complete function, it hits the Cortex router. If the model you requested is available locally, the router sends it down the top path to the local LLM compute. However, if you request a model that isn't hosted in your region and cross-region inference is enabled, the router takes the bottom path. It securely bridges the geographical gap, processing the data at the remote region LLM compute and instantly returns the generated output back to your local account. The complexity of the network hop is completely abstracted away from the end user. Why should a senior architect utilize cross-region inference? The first and most obvious reason is capability access. If you want to use top-tier models like Anthropic's Claude 3.5 Sonnet, but your data is housed in a smaller, regional data center, cross-region inference bridges that gap. It even provides incredible cross-cloud flexibility. You can use this setting to make inference requests from a GCP or Azure region to a model hosted in an AWS region. But there is a massive hidden benefit here: throughput. When you configure your account to allow cross-region inference, Snowflake significantly increases your API rate limits for both tokens processed per minute and requests per minute. For example, a model's limit might jump from a few thousand tokens to hundreds of thousands of tokens. If you are building a production-grade conversational app, this increased throughput is absolutely vital to ensure your users don't experience frustrating too many requests throttling during peak traffic. This comparison diagram contrasts a local-only architecture with a cross-region enabled architecture. In the top local-only box, you are confined to standard rate limits, which introduces high throttling risks for busy applications. You also face a limited model catalog, potentially leading to suboptimal AI quality for complex reasoning tasks. Now look at the bottom, cross-region enabled box. By simply flipping this parameter, you unlock significantly increased tokens and requests per minute, enabling true production scalability. Furthermore, you gain access to all frontier LLMs, ensuring you can deliver the highest AI quality to your business users, utilizing the absolute best model for the job, regardless of geography. Let's discuss how we actually turn this on. Because routing data across regional boundaries has compliance implications, Snowflake makes this an explicit, opt-in administrative action. You govern this using the Cortex-enabled cross-region parameter. To enable it for standard commercial workloads, an account administrator simply executes an alter account statement, setting this parameter to any region. This tells Snowflake it has permission to seek out the requested model wherever it is hosted globally. If you are operating within a supported government-authorized region, you must be more restrictive and set the parameter to AWS US. Diving deeper, this parameter design is brilliant for governance. It ensures that data engineers cannot accidentally send data out of a sovereign region unless the central administration team has explicitly evaluated the compliance rules and legally authorized the data movement by flipping this exact switch. Let's trace the configuration lifecycle using this sequence diagram. The process must start with the account admin on the top left. They execute the alter account command to set the Cortex-enabled cross-region parameter to any region. The Snowflake configuration database confirms the update. Later, a developer attempts to call the AI complete function, requesting a model like Claude 3.5 Sonnet that isn't hosted locally. The Cortex LLM engine intercepts the request, checks the parameter, sees that cross-region is authorized, safely routes the prompt across the geographical boundary, and returns the response. If the admin hadn't set that parameter, The final step would have been a hard failure, protecting the data boundary. With great power comes the laws of physics. When you enable cross-region inference, you must evaluate the impact on latency. Because your prompt and the model's response must physically travel between different data centers, sometimes across oceans, inherent network latency is introduced. The exact millisecond delay is highly dependent on your cloud provider's backbone infrastructure and real-time network congestion. As architects, we must weigh this trade-off. We are accepting a slight increase in round-trip network time to gain a massive upgrade in cognitive reasoning from a larger, smarter model. For asynchronous tasks like batch document processing, this latency is entirely negligible. For real-time conversational chatbots, it requires careful tuning. Because every network topology is different, Snowflake strongly recommends testing your specific use case with a proof of concept to guarantee the total response time meets your application service level agreements. This execution path flowchart breaks down the components of total response time. An application request comes in and hits the execution path fork. If it stays in the local region, we experience near zero network latency before hitting the inference processing time. If it goes cross-region, we encounter an added propagation delay. However, notice that both paths eventually hit the inference processing time node. This is critical. A massive model hosted cross-region might process a complex reasoning task so much faster than a small local model that it entirely makes up for the added network delay, resulting in a faster total response time. You must test both to find your optimal architecture. Now we address the most critical topic for your Chief Information Security Officer: data residency and security. When data leaves its home region, does it violate compliance? Snowflake architected cross-region inference with a strict zero storage rule. This means your user inputs, service-generated prompts, and the model outputs are never stored or cached in the remote region during cross-region inference. The data exists in memory just long enough to compute the answer, and then it is instantly destroyed. Furthermore, if your source and destination regions share the same cloud provider, like Azure to Azure, the traffic stays entirely within the provider's highly encrypted global backbone. It never touches the public internet. If you are crossing clouds, say GCP to AWS, Snowflake secures the transit using Mutual Transport Layer Security, or MTLS. This ephemeral, highly encrypted pipeline means that even organizations with strict data residency requirements can often leverage global AI, because the data never actually resides in the foreign jurisdiction. Let's walk through this security flowchart. On the left, your enterprise data lives safely at rest in your local home region. During a cross-region request, the prompt moves across the boundary via encrypted transit, using MTLS if crossing cloud providers. It arrives at the inference engine in the remote AI region. Look at the critical dotted line pointing to zero storage/no caching. The remote region is strictly a processing zone. It acts as a temporary calculator. Once the inference is complete, the memory is purged, and the encrypted result is sent immediately back to your local home region to be stored. Your data's permanent home never changes. As senior experts, we must govern the financial impact of our architectures. The cost structure for cross-region inference in Snowflake is exceptionally generous and predictable. First, billing locality. Compute credits are considered consumed in the requesting region. If your account is in US East 2 and you ping a model in US West 2, your bill will show the consumption originating from US East 2. Second, and most importantly, you do not incur any data egress charges for using cross-region inference. Snowflake completely absorbs the cost of moving the data across the cloud provider networks. You are only charged the standard AI compute credits based on the number of input and output tokens processed by the LLM, according to the standard Snowflake service consumption table. This means you can design your AI pipelines to use the absolute best model available globally, without having to build complex financial models to estimate unpredictable network egress penalties. This financial flowchart breaks down your invoice. A cross-region inference call triggers two potential cost vectors. On the left is the token processing cost. This is simply billed to your source region based on the standard consumption table for that specific LLM. On the right is the network egress cost. Because traversing regions usually costs money in the cloud, you might expect a charge here. But as the flow shows, this is absorbed by Snowflake, resulting in $0. These two paths merge at the bottom into a highly predictable total cost. You are paying purely for cognitive AI power, completely isolated from cloud networking fees. Let's cement this with a highly important real-world use case. Imagine a major European retail company whose entire data cloud is hosted on Azure in the West Europe region. Their customer success team needs to deploy an advanced RG chatbot that requires the complex reasoning capabilities of Anthropic's Claude 3.5 Sonnet to accurately resolve difficult support tickets. However, let's assume that specific model is hosted in the AWS Frankfurt region. The solution is seamless. The Snowflake account admin simply enables the Cortex-enabled cross-region parameter. Now, when the support app queries Cortex Analyst or the complete function, Snowflake automatically routes the request from Azure in the Netherlands to AWS in Germany. The data travels over a highly secure MTLS tunnel. Claude 3.5 processes the text entirely in memory without saving a single byte to AWS storage, and the insight is returned to the Azure tenant. The company solves their customer issues using Frontier AI, stays compliant with EU data residency, and pays absolutely zero network egress fees. Follow the data in this cross-cloud sequence diagram. The support app, living in the Azure EU environment, asks for a ticket summary. The Azure Snowflake tenant recognizes that cross-region is enabled and initiates a secure MTLS transfer to the AWS Snowflake region, hosting the Claude model. The critical phase is the process in-memory note over AWS. This guarantees no data spillage into the foreign cloud environment. Once computed, the summary flows back to Azure and is displayed to the agent. A multi-cloud, state-of-the-art AI pipeline executed flawlessly in milliseconds. As we conclude, we must highlight the architectural limitations of this feature. First and foremost, cross-region inference does not support your custom fine-tuned models. Inference for a fine-tuned model must take place in the same region where the model object is located. If you need it elsewhere, you must use standard Snowflake database replication to copy the model object to the new region. Second, if you operate in the highly secure US SnowGov regions, cross-region inference is entirely disabled to maintain strict federal compliance. Finally, be aware that Cortex Search cross-region capabilities vary and aren't supported in all regions natively. Understanding these constraints ensures you design resilient, compliant AI applications. Thank you for joining me in this deep dive. I invite you to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final decision tree summarizes our architectural limitations perfectly. When applying cross-region rules, you first ask, is it a fine-tuned model? If yes, it's not supported via the API. You must use DB replication to move the object. If no, you ask, is it a SnowGov region? If yes, you hit a hard boundary and it is not supported. If you pass both of these checks, you are fully supported to proceed with secure MTLS inference routing. Factoring these checks into your design guarantees your architecture is fully validated and production ready. See you at quicktechie.com.